All right, so I'm going to show you one example because that's the example you'll have in the homework. So we'll solve it together here. We have two questions here, example 1 and example 2. Example 2 was in the last year midterm, it was in I think 2018, not last year. So what I'll do is I'll solve question 1, and it's the same process you'll use for the question 2, so you can do the question 2 on your own. But if you have question, you can ask me, but it's the homework question is very similar to that, so you'll have chance to do that there too. Let's say question 1, impact of addition of compost to remove pollutants. So let's say the question was, if you mix compost with native soil, what would be change in removal and transport time of a contaminant through the filter layer? So the filter layer, the depth is given 18 inch. Okay, that's the depth. That's the filter layer. Okay. Stormwater move through here. And assume that addition of compost would increase organic carbon fraction by 5 times. So before and after, let's write that one. Okay. So before addition of compost, your organic carbon was whatever amount, FOC was something. Okay. And after addition of the compost, it become 5 times. The new FOC after this slab is FOC times 5, whatever the previous one. Assume your bulk density is 2.2. So bulk density was 2.2 gram per centimeter cube. And after, we'll look at that, and porosity was 0.4. That means 40% of the filter media is porous. Assume that bulk density and porosity due to addition of compost didn't change. So that means after is also same as before. Okay. And it says KOC, that's the contaminant properties. KOC was that you are not going to change because of design, because that's the contaminant properties is equal to 1 kilogram per liter. And FOC of original soil was 1%. Actually, it's given here. So that's 0.01. So it becomes 0.05. Okay. So I asked you what would be change in removal and transport time. So let's say transport time. Transport time before for the pollutants. If you write that equations, T equal to distance K I porosity 1 plus ball density times FOC KOC times porosity. Okay. If you put all these values here, you will be able to calculate. Distance is 18 inch. Okay, so that's fine. We'll write that. So T after distance over K I 1 plus ball density didn't change. Okay, porosity didn't change, but fraction of organic carbon changed. It becomes 5 times FOC. Okay, and then KOC was whatever it was, same pollutant. Nothing has changed. Okay, if that's the case, if I ask what's the change, because you don't know the hydraulic conductivity, that means I'm asking what's the ratio. Okay, so if you do T before by T after, or T after by T before, how many times it changed, that would be, if you do that one, it cancel all those things. These are all cancelled because it doesn't change. Okay, the only thing that it becomes is rho n plus rho b FOC KOC n plus rho b FOC, KOC, okay, 5 times. So if you substitute those values, porosity was 0.4 plus bulk density was 2.2 gram per centimeter cube, 2.2 gram per centimeter cube. FOC was 0.01 and KOC was 1 kilogram per liter. 1 kilogram per liter is same as 1 kg. It's same as 1 kg is 1000 gram. 1 kg. And then 1 liter is equal to, or we can say 1 liter is equal to 1000 ml. So you can, 1 ml is 1 centimeter cube. 1 ml is 1 centimeter cube. So you can say everything cancels, it's the same unit. So the same as 1 gram per centimeter cube. So that's one. The unit is actually different. Unit is, this is a wrong unit. So it should be liter per kg. Otherwise, it will cancel. So it will be 1 centimeter cube per gram divided by 0.4, 2.2 times 5, 0.01 times 1. So whatever that answer would be, that's the time difference. And it says, what's the change in removal? Removal is, so this is a question somebody asked on Piazza. What does removal means? Removal means what percentage of contaminants removed with respect to initial amount of pollutant. So that will be C final, C out minus C in divided by C in times 100. That's the removal percentage. Okay. So if you solve this one, it will be actually 1 minus C. No, I'm sorry, C in minus C out, because usually you expect C out to be less than C in. So that's why it's written, just to make sure this is positive. So that will be C out by C in. Okay. And retardation factor is also when you say velocity of pollutant, it's also a relation of concentrations. So if you know retardation factor, then you know how less likely the contaminants will be. What's the ratio of let's see, retardation factor is, if you see at the very beginning, what's the retardation factor? Let's go back here. So it's a retardation factor is contaminant solved by dissolve. So if you know retardation factor, you should be able to calculate how much of pollutants are being removed by the sediments, because that's related to KD. So if you know that one, you should be able to see what percentage of total contaminants are actually being removed. So it's already 5:17. So what I'll do is I'll solve that with the second question later, but you know the concept at least. So you should be able to solve this particular question that has similar informations to calculate those values. I think that's it in terms of the